All right, welcome everyone. We're on a second talk for today. And as the next speaker, I'd like to welcome Dr. Lovkesh Vig. Dr. Lovkesh Vig is a senior scientist at TCS Research, and he also leads the deep learning and AI research area at TCS Research, New Delhi. And he has been involved with AppCare in the past. And he has. All right, welcome everyone. We're on a second talk for today. And as the next speaker, I'd like to, and he has co-mentored several of our projects in AppCare. Today, he would be speaking on the topic of Doomsday or Utopia, basing for an AI-shaped future. And personally, I'm very excited about this topic because we've had a lot of recent work on this and a lot of recent books on this, even in the popular culture, like books by Yuval Noah Harari and others. So I guess it's a very good topic to be kind of discussing. So let's just get on with it.
Right. Well, thank you for inviting me for this talk. It gives me an opportunity to discuss things I don't normally discuss on issues that I think deserve more attention. And that's why I chose this slightly provocative title. So, I mean, it's important to understand that all of you are living and are going to live through an era of very rapid technological advancement, right? When I was a student like you guys, we were celebrating the sequencing of the human genome, right? And less than 2 decades onwards, we already have systems that can edit out disease-carrying genes. Sensors have become 100 times cheaper than they used to be. And that has partially been responsible for the advent of the self-driving car. Solar panels and energy from solar panels and wind is now cheaper than energy from coal-fired power plants, which was unthinkable back in the day. Manufacturing has undergone a sea change, and now pretty much anyone sitting in this talk can become a manufacturer simply by procuring a 3D printer and the appropriate CAD files, right? What I'm getting at is that all these advances in all these different fields are producing, have one thing in common, and they're all producing vast volumes of data. And coupled with the advances that we're seeing in data-driven AI and machine learning, they're very likely going to lead us into an era of technological hypergrowth, not just growth, but hypergrowth, right? And that has implications for us as a society, as a community, and for really, it even in some ways influences our chances of survival as a species. So I'll come to this. So before this, I just kind of try to give everyone a sense of where we are in the world of AI and where we're headed in the next. So that's what the first half of this talk is going to be kind of around. And so ever since Alan Turing kind of first postulated the question, can machines think, in his seminal paper way back in the 1940s, he gave birth to this field called artificial intelligence, and many branches sprung out of AI. In some branches included logical symbolic reasoning, some branches included causal inference, other branches included things like reasoning under uncertainty and probability and so on, right? But the field that, the branch that really caught the industry's attention in the 1980s was this branch called machine learning, which dealt with the business of making predictions from data, right? And it was only in the last decade, or around 2010 onwards, when deep learning, which was a subset of machine learning that used artificial neural networks for learning kind of hierarchical representations, really started to take off and has propelled and has kind of solved problems that we thought as a community were decades away from being solved. Right. Now, if you've been following the AI news at all, most of these headlines that you're seeing here would already be familiar to you. Right? But what's common amongst all these headlines is the impact that deep learning has had on AI in general, and how it's kind of pushed the limits of where we thought we were in terms of kind of predictive modeling, right, and pattern recognition. So what is deep learning for people unfamiliar? It's really just an old branch of machine learning that has been kind of rebottled in a new kind of brand, which we call deep learning. Now, the field of neural networks itself is over kind of 5 decades old. And in some sense, it's kind of a toy model of how human brain processes work, but it's a very toy model. It's nowhere near as complex as the inherent structural biases present in the human brain. But it has revolutionized the world of vision, speech, and text, and kind of pattern recognition in general. And it's important to recognize, while there have been many overhyped technologies in the past, that the kind of progress that we've seen with deep learning, at the kind of pace we've seen it, has never really happened before, right? And this is an old slide that I like to kind of present from the Microsoft's speech group, just to kind of highlight how kind of clueless the community seemed to be, especially if you look at this speech recognition graph, how clueless the community seemed to be on how to lower, how to lower the errors on public data sets, on public benchmarks in speech recognition, before deep learning was really applied. And now, ever since deep learning has been applied, the error benchmarks continue to fall, even as we speak. And similar stories in vision, and really the emerging story is in text, where just about 5 or 6 years ago, Thomas Mikolov came out with a way to kind of generate vectorized representations of text, right? And before this, the traditional pipeline for machine learning, it's important to kind of understand how the field has moved. You basically had to take your raw data and hire an expert in either speech or vision in order to kind of extract features that the expert, based on the years of experience that he or she may have, would extract from the raw data and then feed it to a standard kind of machine learning model in order to generate predictions. The problem with this was that it was heavily dependent on human expertise, which was expensive and often hard to find, and made guessing the right features for each kind of data very, very challenging, even for the most kind of qualified experts in the field. You had standard features like SIFT and SURF that were patented, which made commercial use very unviable. And furthermore, there was no obvious way to compose higher level features from the features that were initially extracted. So the question on every
I think the stream is stuck because we have some like activity in the chat and they say the stream is stuck. So could you like refresh the browser window and let's try to reconnect again? Yeah. Yeah. Let's try that first.
Hello?
Right. So let's just start again from traditional machine learning because that was where we were stuck.
All
And
right,
yeah.
sure.
So is it all right now? Can everyone hear Dr. Lovkesh? Right. Okay.
Okay, so as I was saying, traditional machine learning before the advent of deep learning proceeded in this kind of pretty creaky pipeline where you used to take your raw data and you would hire an expert in a particular area, like a vision expert or a speech expert. And that expert would use their years of experience in order to extract features from raw data and then feed those features into some standard machine learning models, again based on their own expertise. Right? And this pipeline had many limitations for commercial use because it was heavily reliant on human expertise, which was expensive and often not even available. And also, even for the most qualified experts, guessing the perfect set of features for each task was impossible. And then the features that were kind of standardized and worked for a number of use cases like SIFT and SURF are patented, and therefore that makes their commercial use a little difficult. And further, there was no obvious way to combine these features to generate more complex, useful features. So there was no compositionality kind of built into these systems. So the question is on everyone's mind at that time was, is it possible to build models that automatically learn complex features relevant to a particular task directly from raw data, right? And the answer emerged in the form of deep learning, right? And it can be traced back. I mean, a lot of the work can be traced back to these first experiments by Hubel and Wiesel, who were investigating the response, investigating basically the cat's visual cortex, and they stuck electrodes into the cat's visual cortex and measured the response of those electrodes to visual stimuli such as the presence or absence of light. And while the neurons did not react to the presence or absence of light, what they found was that the neurons did react. Some neurons did react to the presence or absence of edges in a particular orientation. However, further investigation revealed that if you change the orientation, there were other cells that would respond to edges in any orientation, right? And these were called, simple cells and complex cells, and then there were hypercomplex cells that would respond to shapes like triangles and so on, right? And so this gave birth to the notion of a feature hierarchy, that there's a hierarchy of cells within the visual cortex, and they are connected where lower level cells feed inputs to higher level cells and so on. And this is kind of consistent with the way deep learning works, where the initial layers are detecting low level features like edges, and the higher level layers are combining them to recognize more complicated shapes like a cow or a swan or a car. Now, about the same time as Hubel and Wiesel's experiments, people were trying to kind of model the human neuron, and Rosenblatt's perceptron model was really exciting a lot of people before Marvin Minsky kind of shattered wrote a paper that exposed the limitations of the perceptron and kind of disappointed the entire AI community and kind of led to massive funding cuts. And for the next 20 years, that period is called the first AI winter, right? And that was until 1986, when a paper by Rumelhart and Hinton et al. Kind of reignited interest in neural networks by inventing a technique they called backpropagation. It basically meant that you could learn the parameters of a neural network simply by looking at the error gradients for those parameters, right? Now, this was not the first time this idea was proposed, but it was certainly the most influential of all the papers that were proposed, and is regarded as the seminal paper for kind of the rebirth of neural networks. Right? Later in the 90s and early 2000s, Hochreiter and Schmidhuber outlined a problem with training deep networks with backpropagation, especially when you went from shallow networks to more deep networks with a larger number of layers. And they called this problem the problem of vanishing gradients, which basically implied that there's a multiplicative effect by which these gradients are computed as you go deeper into a network. And what that results in is that the gradients either shrink or explode, which makes learning much, much harder. So Schmiduber and Hinton both came up with solutions to the problem, to this vanishing gradient problem, for recurrent and feed-forward networks, respectively. And these discoveries really opened up neural architectures to previously unexplored depths and helped usher in the current deep learning revolution. Right? And these are really the big three, I would say, of deep learning. I know Joshua Bengio is kind of muscled his way into the ACM Turing Awards, but in my opinion, these are the three really founding fathers of modern day deep learning. You have Jan LeCun, who's invented convolutional networks. You have Jeff Hinton, who really was the first one to look at these deep representation learning capabilities of neural networks. And then you had Schmiduber, who invented LSTMs, which is the foundation of most sequential data modeling work, right? And it's not surprising, actually, that these three are, one is the head of Facebook AI, one is the head of Google AI, and the other is kind of heading the HCL laboratory, right? Now, but based on Hubel and Weisel's discovery of feature hierarchies, a generation of neural architectures were being built. And really, it was Lanette in 1989, which was the first deep model to make learning via backpropagation work. And first commercial application was to automatically read handwritten digits in checks, right? Now, CNNs were able to capture spatial correlations that proceeded to change the world of vision forever. But in the early 90s, you didn't have the kind of data that you have now, and you didn't have the kind of processors that you have now. So all this really limited the application of CNNs way back then. But the technique had been invented, and all of this changed in the last decade as CNNs were given access to GPUs and almost unlimited data, right? And the first wave of deep learning really came about in 2011. People got wind of Schmiduber's team beating everyone else in this traffic sign recognition competition in IJCN in 2011. And then barely a year later, Hinton's team managed to beat, by some distance, some of the best computer vision teams in the world, simply by using a deep convolutional neural network without really too much of domain knowledge around computer vision. So this really kind of led to a flurry of use cases around convolutional neural networks, and people started using it for everything from food recognition to activity recognition to facial recognition, drone-based surveillance, traffic modeling, and so on, right? So a lot of applications started coming through. And lest you think that all the ideas around deep learning are kind of old and dated, and it's just a matter of giving them kind of compute power, what's really happening, there have been some very kind of important new ideas that have emerged over the last decade or so that are worth mentioning. The first of which is these deep generative models. I'm not going to go into the details, but you've had two kind of major landmark breakthroughs with variational autoencoders and GANs. And they both work in slightly different ways, but they've managed to kind of yield performance that has enabled very complicated applications, such as, one in particular that should be of concern to society in general is the ability to generate fake videos. And, we're all probably familiar with this already. But even more interesting applications, such as generating new designs for cars, filling it and restoring images, neural style transfer, and so on. The performance that these networks manage to yield, these generative models manage to yield, is something that surprised a lot of people. The other big new idea was using deep learning, combining the power of the deep learning with reinforcement learning, where the idea is, can you kind of use the functional approximation power of these neural networks to generalize over states in reinforcement learning? And in particular, the initial application that got a lot of attention was the ability to play these Atari games, right, which have a good variety of games and a good variety of but the controls are always the same. The control is always encoded via a joystick, so there are 8 possible moves at every step. And the idea was that everything, instead of encoding a separate state space for every game, just allow a convolutional model to kind of learn a representation of the screen and use that as your state representation, right? And that kind of yielded state-of-the-art performance on all of the Atari games, and things have moved much farther beyond that. And now, where you can even play War of Warcraft, etc., on using these reinforcement learners. But again, the headline-grabbing achievement of DeepRL was this ability to beat the best Go player on Earth using deep reinforcement learning, but just by training against itself. So you had an AlphaGo system that actually it was later on called AlphaGo Zero, which was capable of just training against itself and improving over time to the point where it could beat the best player in the world 4-1. And this again has kind of some kind of social implications, because what ended up happening was that not only did Lee Sedol, who was the current champion, lose, he got so depressed he kind of quit Go altogether, and he said, "There's no point anymore. It's not fun anymore." So something to think about. How do we deal with the psychological issues of machines starting to outperform humans on tasks that we traditionally thought they never could, right? Another big new idea that came about was that of meta-learning, which is kind of still pretty hot, which is the idea of being able to learn from prior experience. Instead of simply learning on each task from scratch from a new data set, can I now leverage prior experience from all the tasks that I've seen to do better in a new task, right? And there are lots of techniques that have been proposed under the broad definition of meta-learning, including using pre-trained models, using gradient-based meta-learning, using domain adaptation, and so on. But this is really where these networks can start doing things that are very useful with very limited data. And that's really where the field is trying to move towards. Can we make these models, which are traditionally very data hungry, better utilize past experience? The other big idea, as I mentioned earlier, was the use of word embeddings, which came about in around 2013 or 14, right? Which Thomas Mikolov and company came out with Word2Vec, and now you have much more sophisticated embeddings that are being used for almost every standard NLP task that you can think of, right? Another development that's happened is the ability to kind of ingest relational information in the form of graphs, right? And so you have these graph neural networks that can ingest a graph and predict node labels and link labels and generate new graphs and subgraphs. And so very powerful techniques that are being applied to scientific applications for determining properties of chemical structures, biological networks, and are being used across reasoning over knowledge graphs as well. Right? Another very recent big idea is the use of self-supervised learning, where the idea is that you kind of blank out part of the input, and then you try to predict that. And this simple technique doesn't require any annotations on the data. It can be done in a kind of unsupervised way. And it's resulted in some very powerful embeddings over the past couple of years, I'd say, especially the BERT and the XLNet, the GP2. They're all kind of based on this semi-supervised learning concept, and they're kind of radically moved the state of the art from where it was before these techniques were applied. And Jan LeCun also believes that the future of computer vision is largely going to be self-supervised. Because he wants to get away from data, from annotated data, and in general, right? It's also being heavily used in robotics, because that's another area where you don't want to have a lot of data in order to learn. Especially as you move these reinforcement learning ideas to the real world, you don't want to be experimenting too much in order to do something sensible. You don't have that luxury, especially if you think of things like autonomous driving, right? So a big consequence of this self-supervised learning and the models that have resulted from it is that machine translation performance has really improved to the degree that they've already kind of surpassed humans in terms of speech recognition and in at least in clean environments, and are we're kind of at the cusp of maybe a stage where for languages that are kind of have enough data, a Babel chip may not be far away, right? And this has huge implications for global communication and the future of language and how we communicate with each other in general, right? So this is going to make perhaps a more integrated society going forward, right? All right, so just current and future trends before I go on to the next half of this talk is that deep learning really has exploded over the past few years, and it's largely due to things like hardware advancements with GPUs, industry giants like Google and Facebook investing heavily in people and research. The community is very open, and there's code that is freely available for most things, and you can just build on that code and publish a new model in archive in a matter of days, a process which previously required peer reviewing and re-reviewing and rewriting, and that whole turnaround time for papers has become much shorter than it used to be, right? And things are likely to only get much more intense going forward, where the number of attendees at NIPS is doubling every year. It's become crazy now, where basically all registrations expire within 5 minutes of the conference. And there's custom hardware now for deep learning. Deep learning is moving on to mobile phones. And some people are kind of worried about this fast progress, and they're worried enough to kind of invest billions of dollars on ensuring that this technology stays ethical, right? And as capabilities continue to get enhanced, it's only a matter of time before these deep models are married with symbolic and causal reasoning, which is, in my opinion, the next big leap for AI. Now, India, unfortunately, was very late to the party as far as deep learning is concerned. And I remember back in 2016, there were only a handful of researchers even working on this area, and virtually no students at all that you could choose from while recruiting who were trained in deep learning, right? So this needed to change fast, and it has to some degree. But the field is still currently dominated by the Googles and the Facebooks of the world, who kind of assemble deep learning armies. And if you go to any major AI conference, it's kind of embarrassing that India, which is considered an IT superpower, has such poor representation in these conferences, right? So the idea is we need to be relevant enough in these conferences and these places to participate in these decisions that will inevitably shape our future through AI going forward. And even people like Elon Musk and Stephen Hawking have cautioned against, being very careful with the technology and how powerful it can be, and it could, in the wrong hands, lead to catastrophic situations. Right. So let's look at some of these threats that people are pointing to. So the first threat that people think about when they talk about AI is the threat to employment, right? And it's a very real threat. I mean, a lot of people try to minimize this threat by saying, no, AI is going to create more jobs than it's going to destroy, and so on. I don't think that's entirely true. I don't, especially for a country like India, where 70% of the population is engaged in tasks or jobs that are highly automatable, right? And I mean, this pandemic has perhaps brought that really to the surface, because I mean, even in my own house now, I have this robot that cleans my house, cleans my floors, and I'm actually wondering why I need a human to do these tasks at all. And so now imagine the consequence of that as this technology spreads across the country and potentially unemploys millions of people engaged in household chores, right? Gainfully employed by being maids and so on, right? So this is a huge kind of problem that is going to hit. It's not going away, and it needs to be addressed. And looking the other way and pretending it doesn't do any good, in my opinion. So let's take a look at what solutions are out there and what's likely going to happen. So this is likely going to lead to huge concentrations of wealth and power, right? And it might even lead to a situation where it'll be very, very difficult for somebody to climb the economic or social ladder, because if there's a very limited opportunity to work, there's limited opportunity to kind of climb the social or economic ladder, and could potentially lead to political and social unrest. On the flip side, however, it will probably result in lowering the cost of goods and services, right? And the idea is that if costs go down faster than unemployment rises, perhaps we can manage this transition as jobs are lost, right? But the point is that the transition does have to be managed both politically, economically, and socially. And we have to think about the effect of this on our entire psyche. Now, many people hate their jobs and would gladly quit as long as they keep getting paid, right? However, for some people, their job is their identity, and people have the need to feel useful, right? So we can't look at a crystal ball and predict what's going to happen, but we can look at case studies that happened in the past. So you look at a town like Youngstown, Ohio. This was a prosperous town until the 1970s. And all of a sudden, a lot of jobs got shipped overseas. And that resulted in a spike in cases of depression, spousal abuse, suicide, etc., more than triple the national average. Right? So there are psychological effects that, besides just money, this is also a question of, preparing society for an environment where not everybody is employed, right? And if you think that these issues are far and away from now, think again, because Switzerland just had a referendum I think 2 or 3 years back, where they voted on whether or not to have a universal basic income. Now, the motion was denied, but you can easily see that as things get more dire, the motion may get passed in the future. Sorry. And the question is, what about poorer countries like India? Do we even have that option? We don't even have enough money to distribute to everybody. So do we have a viable model for economic wealth redistribution, right? We need to think about this, right? So, and then there's the rise of totalitarian technology, right? You already know that your phone is constantly spying on you. In some states, some countries, you don't even have the option of leaving your phone behind or switching it off, right? China, for instance, right? So, and contrary to popular belief, it is possible to secure the phone. It's just not convenient for a lot of businesses to allow you to do so. And so there's this constant battle between privacy and convenience. And generally, short-term convenience tends to win out over long-term consequences due to privacy, right? Which is sad. And this is how kind of your right to privacy and free speech gets slowly chipped away until, and it's a slippery slope, right? Even in democracies, people kind of naively trust institutions to guard their privacy. And US, for example, has an operation called Quiet Skies that looks at behavioral patterns of flyers to determine potential threats. And this could be as innocuous as people visiting the loo too many times, right? But China by far has been the worst offender, and has initiated a social credit system in 2020. Now imagine this, where everything you do is assigned a score, whether you get a traffic parking violation, whether you cross a red light, whether you, I don't know, any and every action of yours is recorded, scored, and filed away for future reference. I mean, that's called a social credit system, and it's terrifying to me, right? And now what's even more frightening is that tech can now influence election outcomes in free democracies, right? So social media, we've already seen, is a determining factor in election outcomes. Fake content, thanks to deepfake and all this, and all the generative model stuff that I was talking about. Fake content is easy to generate and use to manipulate public opinion. Like it has never really been as easy to manipulate an election as it is today, right? And the global effects you can see are already manifesting with thriving democracies, once thriving democracies moving towards kind of totalitarian regimes, and it's a slippery slope. So we have to be careful to protect our rights, right? So what can we do? We can firstly not trust anything on social media without verification from an authenticated and reliable news source. Governments will always want your data. Citizens have to push back to demand privacy and demand that it not be compromised. And the judiciary has a key role to play, right? And there's also we can also fight back with privacy preserving technology. And this is the kind of burning issue of our times. And we should be aware of how we use our apps and websites when you're using data. And I would oppose any law that forces somebody to carry a cell phone or allows the government to snoop on it, right? So another very concerning development, nauseating development, really is the future of in what I call the future of war, lethal autonomous weapon systems. So these are systems that have really come online over the past 5 years or so. When I was a student, doing my PhD in 2005, you needed 5 soldiers to operate a single bot in the field. Now that ratio has kind of been inverted. And now we're in a situation where complete autonomy is almost possible. So a robot can autonomously decide to take a human life. The question is, are we willing to allow such systems to operate in the field, right? And there's been a recent use of this in Dallas when they used a robot to detonate a bomb to kind of neutralize a gunman who was hiding inside a building, right? And the nightmare scenario really is that you have an integrated set of bots that are operating in the air, on the ground, and at sea, that are communicating with each other intelligently and kind of, I mean, conventional weapon systems would not stand a chance. And this is not something that I've cooked up. This is something that defense agencies across the world are thinking about. And some people have said these are potentially deadlier than nukes, and I would agree to some degree, because while nukes are more catastrophic, they're harder to acquire and harder to detonate. But one can potentially acquire a fleet of drones for a little bit of money and make a very destructive kind of fleet. So the US and other G5 countries are actively engaged in developing these weapons, right? And ironically, the same countries are drafting a UN resolution to ban the use of these weapons. And there are voices of protest from the scientific community which are now spreading. In my view, banning these is in everyone's interest, and we must insist on humans in the loop, even in these dangerous missions. And we've done this before once with chemical weapons, where we've successfully kind of banned their use, and we should be able to do it again, right? And the same technology can be put to much better use for disaster relief, right? So same technology, situations like fires, earthquakes, and terrorist attacks, which are dangerous for humans, a bot is better able to bear the extreme conditions and can provide life-saving assistance. But again, the critical decisions must reside with the human in the loop. All right, coming to cheerier subjects, on the positive effects that AI might bring. So AI is now in a position, thanks to the advancements and plus the data that's now available, we can combine the medical, genetic, and radiological information from millions of patients in order to arrive at an informed diagnosis and prognosis for a particular person, right? And then, of course, this raises additional security issues, because now these implanted digital health devices, which are becoming very popular, such as pacemakers and insulin pumps, are also hackable, as has been shown. So that's another layer of security for society to worry about, right? But looking at the bright side, I mean, in view of this pandemic, and while it seems like we've been trapped in our homes forever, the scientific community has made amazing progress. I mean, we're barely a year since the outbreak, and we already have several vaccine candidates, and a lot of this has been made possible by AI, right? especially companies like Moderna have famously used AI for drug discovery for a while now, and they have a potential vaccine. So TCS, I'm just going to plug what we've done, and in the context of India. So we kind of first have a multilingual conversational agent that disseminates information to everybody about COVID and how to stay safe. Then, as we know that the information about this virus continuously evolved, and we didn't really have the full picture. Not that we have it now, but we didn't have a very good picture of the virus and the research around it for a few months, right? And so you needed to wade through the literature in order to find out what if you were doing research in this area, right? And so we have a text mining tool that does this, that allows for easy mining of information for COVID-19. Also, in the Indian context, it's important to know what is likely to happen in the wake of shutdowns and openings and reopenings and so on, and how the virus is likely to spread in these different situations across demographies. And so we have an epidemiological model for doing this. With Professor Ashwin Srinivasan in BITS, we've shown that you can build models on chest X-rays, and other people have shown it on CT scans, that you can actually do a very good job of screening people with COVID-19 in a much shorter span of time with X-rays than you would with a PCR test, right? And finally, of course, we're working with CSIR to evaluate potential drug candidates that we've generated using our AI systems, right? But this was about the pandemic, but the real future of healthcare and the real kind of niche application is going to be in precision medicine. Now, if you were trying to get yourself sequenced in the year 2000, it would have cost you $100 million. That cost has now dropped to about $2,000 and will soon be, just a few $100s. So what that means is effectively almost everyone is going to get sequenced. And that will mean that where you just had a handful of sequence data for only a handful of people, you will now have it for millions and millions of people across disease types and phenotypes, right? And what that means is that now you can apply these data-driven AI techniques to uncover patterns, something that they are best at, right? And perhaps evolve solutions to or treatments for different diseases. Now, and there's already a lot of research around anti-aging, because that apparently there's a lot of money in that. And it's important to understand that, while it sounds very far-fetched, at the end of the day, aging is just a chemical process. If you understand the chemical process well enough, you should be able to do something to slow it down. So it's quite likely that humans in the future are going to live much, much longer than we are living today, right? The lifespan is going to go up, and we have to, again, think about these issues and what that means for society as a whole, right? The future of energy, and in some ways our survival as it's linked to global warming, is that there's currently glaring inefficiencies in the way energy is generated, transmitted, and utilized. And what we can do with AI is identify and remove these inefficiencies by utilizing sensory information and move from time-based maintenance to condition-based maintenance. Now, what do you mean by that? What I mean is, if you have a car right now, you probably give it for servicing, let's say, every 6 months. But you might be servicing parts of your car that don't really need any servicing. And you might be replacing those parts, and wasting resources in the process, right? The reason you do that is because you don't have information about which parts of your car really need servicing or are being worn out, as opposed to which parts that don't, right? So once you have that information, thanks to the sensory feedback, you should be able to conserve resources much better, right? And the other application is in renewable redistribution. So renewables are great, but they're also depend on fickle variables like wind and sunshine and weather, right? So demand is very hard to predict with these demand and supply is very hard to predict with these resources, right? So if you have an AI model that does this and have a smarter grid that kind of redistributes energy between your homes and your appliances, you get much better utilization. All right, so another very pertinent kind of important aspect of this whole technological evolution is the future of knowledge. Where is education going, especially in light of what we're seeing during this pandemic, where everybody's basically learning online, right? Well, even before the pandemic, the value of factual knowledge was already kind of on the decline, right? There's no point kind of just knowing something anymore, because you can just as well look it up on your cell phone, right? But so what really the way to future-proof your career is to acquire the ability to quickly absorb and apply knowledge to solve problems, solve new problems, and that will become steadily more important going forward, right? So in a data-driven world, another kind of aspect to this is, in a completely data-driven world, there's a tendency to have less tolerance for opposing views or for subjective analysis. Especially when there's not a lot of data to support it. But people should be free to kind of explore new ideas, new opinions, even if there isn't a lot of data to support it. And so there's a danger, especially in the humanities, of this getting too rigid, things getting too rigid, right? And then there's the notion of brain-computer interfaces, right? So we can already control devices with EEG signals, right? So, and Ray Kurzweil believes we'll be able to upload our brains, and the singularity will happen by 2040, and all sorts of kind of far-fetched theories that I don't subscribe to. But it is quite possible that we will start to interact with machines much more in a different way than we have been in so far. That is by typing on your cell phone or something like that, right? It's quite likely that we will be interacting with machines via thought, via some kind of different interface. And just so you don't think it's too far-fetched, it's already possible to kind of hook your brain up to an fMRI or an EEG machine and kind of make you think about somebody or something, and kind of peek and kind of draw an image of what you're thinking about. And there's some incredible videos of that on the MIT website. I'd urge you all to kind of have a look, right? So the larger point that I wanted to make was that you guys are at the threshold of some very, very significant technological advancements, and you're likely to see more technological advancement than any generation before you. And where you end up at the end of all that is going to largely be determined by the decisions you make around these social issues that I kind of tried to highlight, right? And whether for better or for worse, the decisions are your generation is going to be saddled with these decisions. So it's best to be informed about them and read up, and not just spend your days building deep models, but also be aware of the larger picture on where the world is heading, right? So with that, I'll conclude, and I'm open to kind of any questions you might have. Thank you.
Thanks for the great talk. I think we'll just move to the question directly, because we have a lot of questions. So, okay. Like, one question is, I guess you can even look at the questions yourself, or I can ask them.
Okay, I have this chat window.
All right, I guess I can ask you the questions.
Go ahead.
So, what do you think about recent compute-intensive models such as GPT-3, which are almost impossible to train because the training costs are too high, such as $40 million, and are these a step away from inclusive deep learning research?
Well, they have made them public. So yes, training them is, you can fine tune them, but yes, training them from scratch is going to be a challenge. But the fact that they've actually made them public, to me, sounds like they want to democratize these models as much as possible. Now, it's not exactly their fault that these models are kind of as big as they are, and as memory intensive as they are, right? Yeah.
Right. And yeah, another question is that can you tell us a bit more about how like Industry 4.0 might affect the Indian scenario of like how so you talked a bit about how students can adjust to this by continually learning and by being very good at understanding new technologies, but can you like expand a bit more about on that?
Right. So, repetitive tasks are on the decline. If the days of just being able to code the same database and write SQL queries and pass your entire. I mean, there are people who have spent their entire careers just writing SQL queries, right? There are people who spent their entire careers just writing the same code over and over again, and I mean those kinds of jobs are hard to they're going to be hard to retain in the future. But people who are capable of taking a problem, absorbing knowledge, the relevant knowledge around that problem, and then solving it and attacking it are the kind of people that are going to be highly valued in going forward, right? That's kind of where I see this whole thing going, right? If you have something to offer that is not easily automatable, right? That is where the value lies as a career.
Right, but another thing is that we keep on shifting the automatable goalpost like ahead by
Right, and that sadly is going to continue. Sadly, or for better or for worse, it's going to continue.
right,
And you have to keep abreast of what's happening. It could very well be that in 20 years down the line, we've already over the past couple of years we've seen systems that are able to translate C to Java. Facebook just came out with something. So all these migration tasks that used to consume a lot of effort and resources are now being done by models, right? And even SQL writing, you can now pretty much do everything conversationally. You don't actually have to write an SQL query anymore. You can just say, fetch me all the employees that were employed before 1990 or something like that, and it automatically understands what the SQL query is, and it produces your result. So even that is going to kind of go away. Um, I don't know when and at what pace, but so the idea is to always be abreast of what is new and kind of be ahead of the curve in as far as adoption of new technologies are concerned, right?
right.
Yeah.
Yeah. Another like related question to this is by Somesh, who asks that when you take away the economic power from people, because like due to due to automation, you also kind of take away their political power. So how do you actually divorce these two things? Because if we have UBI, then in a sense you'd also like take away the political power from people. So is that kind of a concern, and should we be thinking about that?
Right. So these are very hard questions. I'm not claiming to be a political system expert, and I'm not sure. I probably shouldn't, propose a system that will allow you to have a universal basic income and still have your political rights. That is a job of a political scientist. So what I'm trying to suggest here is that economists, political scientists, the greatest minds have to come together and devise a new paradigm under which society can function, where people can retain their rights, where people have a minimal kind of standard of living. And this needs to happen, and not enough attention is going in this direction, um, in my opinion, at least not in the developing world where we live in. And that could lead to pretty catastrophic consequences, because it may seem like Google is a far away, but what if Google tomorrow comes out with a technology that completely automates all the BPOs in India, right? It's already happened to a large extent. all the BPOs get shut down, all your maids start getting unemployed, all the labor is done by machines. I mean, these are and it's clearly happening, but there's not enough discussion around, how we're going to handle the transition when it happens, because people tend to think that it's a long way away, but it may not be. It may happen as sooner than people think.
Right. Also, you touched a bit about Ray Kurzweil and the singularity. So Ray Kurzweil has talked about GNR, which is genomics, nanobots, and robotics. So what do you think, are if we combine these technologies with the recent trends in AI, how do you see these fields progressing in the future? And are there any major trends that we should be aware of in those fields?
Certainly. So yes. So genomics is, I think, as I mentioned in the talk, is ripe for AI. Right. I think it's the field that's perhaps going to benefit the most, because there is just so much data available. There's just so much available in terms of data, and to feed these deep learning algorithms and learn patterns. I don't know enough about nanotechnology to really comment on it, but it's quite conceivable. I have read that these nanobots are now capable of very precisely delivering medicine to an area where it's supposed to go. So currently, if you consume your meds, let's say somebody's suffering from cancer and they take chemotherapy, that medicine is not just going to hit the tumor, it's going to hit the body everywhere, potentially to hit healthy cells as well, right? So what I hear is happening, but I haven't really read enough about it, is that nanotechnology is going to allow you to kind of encase the medicine, the molecule, in a shell, which will only be released when it hits a tumor. So the medicine will pass through the system, the rest of the healthy system, and will only attack the tumor cells. So that's pretty significant development if it's happening right now, I think. And then so you have what was the third? Robotics, right? So yeah, so I guess robotics is kind of included in that. A big trend in robotics that's happening, if people are interested, is offline reinforcement learning. That is learning from past histories without any additional kind of trials or online deployments. So that's a really hot area. So Sergey Levine is kind of the pioneer in this field, and he's published several tutorials, etc. I would highly recommend people interested in robotics be very closely follow Sergey Levine. He's in UC Berkeley. Okay.
Right. I think it has been an awesome talk. We do have some more questions in the questions box, but I'm not sure if they're relevant to the talk directly.
Mm-hmm.
So yeah, you free to actually have a look, and we can maybe go over those.
Okay.
Because
okay, yeah, there's a question about how to follow my publications. So all you have to do is Google my name, and my homepage will pop up, and that has a list of all my publications. So you can directly access it there. Right? Any other? Okay, so I have some consensus on the 3 winners of the Turing Award that I chose.
yeah.
So that's good. And that's it, I think.
Yeah.
Okay.
All right. Thank you for the amazing talk. And I think it gave a very good summary of the whole field and how we've been processing, how the whole history from where the whole deep learning is built upon, and the advances and even the implications that we should be aware of. And I'm sure you've toggled a lot of people over here in the audience, and they'll look at things from a different point of view.
Yeah, I hope some of it sticks.
Yeah.
Thanks.
Thank you for the amazing talk.
Thanks.
So we'll be back after a 1-hour break, and we'll be starting with Professor Snehanshu from BITS and from AppCare. Thank you.